Hello, my name is David Groves from the RAND Corporation. I am going to describe an analysis of impacts of climate change on African water infrastructure performance from Chapter 5 of the Enhancing the Climate Resilience of Africa's Infrastructure book. Let me begin by describing some of the ways in which climate change could affect Africa's water and energy sector and the PIDA strategy. In this table, I list several key climatic changes and the risks and opportunities that they present. These include increasing temperatures, which would lead to water stress and possibly higher irrigation needs, increasing precipitation, which could lead to flooding, however also opportunities for higher hydropower production and lower irrigation requirements, decreasing precipitation, which would also lead to water stress, but in addition lower hydropower production, and lastly, increased hydrologic variability. This could lead to more severe droughts and floodings, as well as low returns on infrastructure investments. However, there are opportunities that, depending on how the infrastructure is designed, it could also lead to higher returns on infrastructure investments. For this analysis, we evaluated climate impacts for the 7 major river basins in Africa, as shown on the left-hand side of the screen. And on the right-hand side, this shows the corresponding power pools, including the West African, Central Africa, Eastern Africa, and Southern African power pools. In the next set of slides, I'm going to show the wide range of future climate conditions as projected by over 20 different general circulation models, or GCMs. This slide shows the projected climate conditions in 2050 for the Congo Basin in terms of the average annual precipitation on the horizontal axis and average mean temperature on the vertical axis. The green and orange symbols show the results from the Intergovernmental Panel on Climate Change's 4th and 5th climate assessments respectively. The type of symbol indicates which global mission scenario is used for the projection. Note that the X's in the lower portion of the graphic indicate different model simulations of historical climate. For the Congo, one can see that all the future projections show warming between about 0.5 degree and 2 degrees Celsius. Most projections also show more precipitation, while a few show drier conditions. This graph now shows the projected climate conditions for the Orange Basin. As with the Congo Basin, all future projections show warming between a bit more than 0.5 degree to 2 degrees Celsius by 2050. Unlike the Congo, however, about half of the projections show drying conditions by up to around 20%. Lastly, this slide shows the climate projections for the Zambezi Basin. All projections show warming by between 1 and 2 degrees Celsius and changes in precipitation roughly evenly distributed between 10% less and 10% more precipitation than historical. Note that there are a couple of outlier results from the 5th assessment results in which conditions are about 2 degrees warmer and over 20% drier. Before we dive into presenting the results from this analysis, I want to remind the viewer of the modeling system that we developed to evaluate climate impacts on the water and energy infrastructure in Africa. What you see here is that we have 3 main computational modules: a water model built in the WEAP modeling platform, an energy model built in a modeling system called Osmosis, as well as an economic cost evaluation module. I'm going to focus on the upper portions of the model, which really focus on the infrastructure performance. And the water model takes information about the reference climate as well as future climates, and then information about the PIDA plus and investment profile, so representations of how the system will be built out over the coming decades. And then the water model produces outcomes related to infrastructure performance. And in order to automate the evaluation of this model many times over many climate futures, we've developed scripts to automate that process, and that developed a large set of results which were stored in a database, and we connected that database directly to an interactive decision support tool built in the Tableau business analytics software. This slide shows the analytical steps taken to evaluate climate impacts and adaptation opportunities in Africa. As mentioned in other presentations, the analysis was presented in 4 stages. Stage A, the reference case, evaluated the performance of the PIDA Plus investment plan under historical climate conditions. The results from this stage helped to benchmark performance without climate change. In Stage B, Climate Change, No Adaptation, we evaluated the PIDA Plus investments under the 121 climate futures. This information was used to identify the vulnerabilities of the PIDA Plus plan and understand the opportunities for adaptation. In stages C and D, which I'll discuss more in another presentation, we developed and evaluated different adaptation strategies. For the remainder of this presentation, I'll present results from stages A and B. This slide summarizes the wide range of climate effects that we see for the Southern African power pool basins, and those being the Congo, Orange, and Zambezi Basin. On the horizontal axis, we show the change in hydropower generation from a simulation using historical climate data relative to all of the 121 climate projections. And on the vertical axis, we show the corresponding change in irrigation unmet demand in terms of percentage points. What we can see here is that for the Congo Basin, very little impact from climate is seen in terms of both hydropower and irrigation. However, in the Orange Basin, we see that there's quite a wide range of impacts on the hydropower sector, from decreases in hydropower generation of up to about 35%, but also opportunities to increase hydropower generation almost up to 50%. Results are similar to Zambezi Basin, although you see even more potential impacts in the hydropower sector, as well as impacts in ability. This graph now takes those same results and presents them in terms of the economic impact of those changes in hydropower and irrigation unmet demand. For these graphs, each of these vertical lines is the result from one of the 121 projections. The length of the bar indicates the change in present value from historical and percentage terms, and the orange portion of the bar represents the change in the hydropower sector, and the blue represents a change in the irrigation due to irrigation. And what you see here is that similar to the previous graph, you see that for most climate projections, you see negative impacts due to loss in hydropower, and then as you get further drier climates to the left, you start seeing impacts in the irrigation sector. And on the far right, you see that for maybe about 10 or 15% of the projections, you see some value increases due to higher hydropower. This slide now shows the same set of results for the West African power pools basins, namely the Niger, Senegal, and Volta Basin. And in this case, all three basins exhibit some significant climate impacts, both positive and negative. You can see here that hydropower generation can be impacted up to from 40 to 60%, but also there can be gains of about the same magnitude. You can also see here that in these basins, there's the wetter climates lead to significant decreases in unmet irrigation demand, particularly in the Volta Basin. So this is a real good example of where there's as many opportunities as there are risks from climate change. This chart now shows the wide range of economic impacts without adaptation in the West African power pool. A little bit more than half of the futures lead to positive economic impacts due to climate change, equally distributed between gains in the irrigation sector and in hydropower. For those futures in which impacts are negative, again, the impacts are equally experienced in the hydropower and irrigation sectors. Lastly, we show the climate effects for the two Nile basins. In the eastern Nile Basin, impacts and opportunities are seen in both the hydropower and irrigation sectors. Impacts under the different climate futures are mostly less than 20%, although the two outlier cases show hydropower generation reductions of up to 30% and irrigation unmet demand increases of around 20%. The Nile Equatorial Lakes Basin shows impacts and opportunities mostly in the hydropower sector. This chart now shows how these impacts translate into economic outcomes within the West African power pool. In a majority of the climate futures, impacts are positive, driven mostly by irrigation gains in the eastern Nile Basin. those futures showing negative impacts are mostly in the irrigation. We'll conclude this presentation with a summary graph showing the ranges of impacts due to climate change, but in this case I'm focusing only on the new infrastructure defined in the PIDA Plus plan. So we're isolating the investments in part because the next stage of the analysis is to focus on those investments and thinking about ways to improve them to be more robust to a wide range of climates. In the top part of this graph, we're looking at the total value of those investments and the range of those investments across the 121 climates scenarios. So the height of these box and whisker plots indicate the full range of value across all the climates, and you can see that, for instance, for the Zambezi Basin, the range of value is about 45 billion to a little bit over 100 billion. Whereas in the Senegal, it's a very tight bound, just a little bit under 50 billion. Then the bottom half of the graph shows the change in total present value relative to the case in which we use historical climate, and you can see here that the percentage change can decline as much as about 50% in the Zambezi and the Nile Equatorial Lakes region, but also increase rather significantly, particularly in the Volta. And with that, I'll conclude. The next presentation that I will be making will go into the third and the fourth parts of the analytical process, where we look at developing more robust adaptations to take advantage of the opportunities to climate and minimize the impacts of climate conditions. Thank you very much.